Okay, lesson 2-2, multiplying polynomials. All right, so before we were factoring polynomials, so now we're multiplying, and this is really just like undoing the factoring. It's like two sides of the same coin, right? Factoring and multiplying. So we've done this before. This was actually in grade 9. You guys have seen this multiplying property. So let's kind of get into it. So it's going to be done with our distributive property, like that rainbow, like I've showed you guys in the past. So feel free to look through these to kind of remind yourself. But I think I'll just get into some examples and talk a little bit about algebra tiles. So algebra tiles are in the curriculum. Tell you the truth, I'm not that big of a fan, and algebra tiles actually stop kind of being so effective once you start getting, x to the power of 3, when you're doing these things. So I'm not gonna rely too heavily on the algebra tiles, but definitely if it's something that helps you, then look through here and you can use them. But for me, let's go down to question 1. So it says, determine each product. All right. So you guys haven't seen this one. I'll give you one that you have seen before. So let's say that we had 3 times x plus 2. Something like that, right? In grade 9, what we did, we said, okay, we got this number 3, and it's just being multiplied by both of these terms, this binomial. So it's being multiplied by the x and the 2. And I often showed that with, that rainbow going in. So that there would just be 3x, right? Just the first one, 3 times x is 3x. And then 3 times 2 is positive 6, so plus 6. Okay? So that's more a simple example there. Now what we're going to do, we're just going to do it with 2 binomials. So I'm going to write this out so we just have a bit more room. So x minus 3 and x minus 5. Okay. And now what we have to do with a binomial is, well, really what's going on here is I need to multiply this x, right, this one term, by both of these things, by x and negative 5. And then I need to multiply the 3 by x and negative 5. And then that would be everything. And then I have, like, I've actually done all 4 different multiplying situations there. So quite often the way this is shown is with arrows where I would go, okay, from this x, I'm going to go x times x, so like that one times that one, and then x times 5, so then that one. And that'll get the first 2. And then it would be negative 3 times x, and then negative 3 times negative 5. So there's going to be 4 in total here. Okay? So let's just do the first one there. So that's going to be x times x. All right, x times x. So like x to the 1 times x to the 1. We add exponents. That'd be the same thing as x to the 2. Okay, so that's going to be x to the 2. Okay, moving on to the next one. So now we're just doing the, blue. We're doing this line over here right now. So we're going to do x times negative 5. Okay, so that's just going to be, well, negative 5x. And that's it. That's all we can do there, right? When you multiply like a variable like x times a constant like negative 5. Okay, and then move on to the next one. So now we've got negative 3 times x. Okay, so negative 3 times x is just negative 3x. So we just write that as minus 3x. And then lastly, we've got negative 3 times negative 5. This is positive 15. Okay, and that's pretty much it. We've multiplied the whole thing, but we can simplify this a little bit more. I can see that I've got some like terms going on, right? Negative 5x minus 3x, right? So those are like terms. So this would all become x squared, and then combining those like terms would be negative 5 minus 3 is negative 8x plus 15. Okay? And then that's my answer. And we're going to go over how you would factor this to get out this in the next lesson there. So that's where we're headed. Okay, so let's do this one again. I'll be a little bit quicker now that we know the skills. So I'm just going to draw my line. So it's going to be the 5m times both of those. Okay, and then the -1 times both of those. All right, so 5m times 2m would be, okay, well, we go 5 times 2 is 10. And then m times m is m squared. Okay, and then 5m times -6 is going to be -30m. Don't forget the m there. That's a common place to make a mistake. And then I'm going to move to the middle ones. All right, so then -1 times 2m. So doing that one. So that's going to be negative, well, 1 times 2 is 2, so -2m. And then -1 times -6 is +6. All right, and then we got the same thing happening here. We've got some like terms. So this would all be 10m squared. And then -30 minus 2 is -32m. Right, just combining those like terms. And then +6. And that's it. All right, so now changed up a little bit. It's really no different. It's just going to be more steps now. So now what we have going on is we have a binomial, right, 2 terms, times a trinomial, so 3 terms. It doesn't really change much at all other than now. So last time we went the first one times, we went this x had to be multiplied by both of those. And then the 3 had to be multiplied by both of those. Well, now we just have to go this r times all 3 of those. Okay, and then the -4 times all 3 of those. So we're going to have 6 terms when we're done this thing, right? If we don't have 6 terms, then you probably did something wrong. Okay, so let's just go piece by piece here. Okay, so we'll do the r times the 3r squared. Okay, so it's going to be 3 because there's nothing out front there. So it's going to be 3, and then r times r squared is r to the 3. Okay, and then move on to the next one. So r times 8r would be positive because it ends up being positive. 8, and then r times r is r squared. All right, and then move on to the next one. R times -6 is just -6r. All right, so we did all the top part of the rainbow there, if you like. So now we just got to move on to the next one. So it's going to be -4 times all 3 of those. So this will be -4 times 3r squared is going to be -12r squared. And then the next one, -4 times 8 is going to be -32r. And then -4 times -6 is going to be +24. Now, if you guys remember all that collecting like term stuff that you guys did in grade 9, this is really why, right? Do you remember how I had you guys circling like terms or putting boxes around things that were like terms? That's a good strategy because what we got to do here is we got to collect all the r cubes, all the r squareds, all the r's, and then all the constant terms on their own, right? So it looks like there's only one r cube, so I'll leave that one alone. But let's do the r squareds. So I'm going to circle those. Okay, so there's my r squareds. Notice that I circled it with the addition or subtraction sign in there too. So those are the things I'm going to have to put together when I do that. And then I think I'll put like a box around my r's. Okay, so those are going to be the things that go together. You'll pretty quickly now have to do this step, I think. We're circling and putting boxes around all the time, but it's really helpful, especially when you're getting used to this. So let's write it all out now. So now we've got 3r cubed, because that didn't change at all. And now I'm looking at my r squareds. So 8 minus 12 is going to be -4r squared. Okay, and then -6r minus 32r is going to be, okay, so negative, and then minus 32, so that's going to get more negative, right? So that's going to be minus 38r. And then we just still have that plus 24 on the end. So plus 24. Okay, so the next one is very similar, but I'm going to do a lot more of this kind of stuff in the even longer questions below. So I'll leave that one for you guys to try, okay? All right. Now, let's do these two monster ones. All right, so now we've just got more stuff. Like, it's actually not any harder. Well, I guess it could be a little bit harder when you got this one, but this is going to be longer. We just got to be really careful as we go here. So what I would recommend, do you see how we've got like this piece, and then we've got this piece, and then there's like an addition sign in between them? Well, I think the best way to handle it when it's like that is to just do this part on its own, and then do this part on its own, and then just combine the like terms when we're done, right? We just want, because we're turning all of this mess into a bunch of just terms in the end, and then we're going to collect all those like terms. So let's just do this front part first. Okay, just ignore the second part for a second, and we'll do our rainbow thing here. So we'll go. It's going to be x times that, times that, times that, times that. All right. So the first part, x times 5x. All right. So x times 5x is just here. I'm going to give myself lots of room here. 5x. That's it. Oh, 5x squared. Sorry, because x times x is x squared, and then x times negative 2 is just negative 2x. Okay, so that's my top part of my rainbow done. Now moving on to the next one, we've got 3 times 5x. So that's going to be positive 15x. Okay, and then 3 times negative 2 is negative 6. All right, so that's it. We did this part, right? Now, let's, well, you know what? Let's simplify it a little bit more. Let's just actually do this part while we're at it. Okay, so then let's turn that into 5x squared, and then negative 2x plus 15x is going to be positive 13x, and then minus 6 still. Okay, so we've done to here, right? So that's what that would all equal. Now let's move on over here. So the way we handle it when there's 3 things multiplied by each other is, well, we'll just do it piece by piece. We're going to put this 4 and we'll distribute it into this one first and then start over from there. The place where students will make a mistake is that they would go 4 times this, 4 times that, and then they'd go 4 times that and 4 times that. That'll give you the wrong answer. We can't do that. Like the 4 is just being multiplied by that one it's attached to there, right? It's not being multiplied by, well, the other one there. That being said, I could, well, hopefully I don't confuse you guys with this, I could just multiply the 4 by just those two and not this one as well, but I can only multiply it by one of them, okay? So here's what we're gonna do. So we'll go 4 times that and 4 times that first, and then we'll regroup, all right? So we'll just go, okay, 4 times x is 4x, and then 4 times negative 1 is negative 4, okay? And then I'm going to put brackets around it, and you'll see why in a second. So I'll put brackets around it, and then I'll write this part out again. So 2x plus 5. Okay? And then we're adding all of this, right? So let's keep that in our mind. So now, the reason why I put brackets around that is because now I have to go this binomial times this binomial. So I need to do my whole rainbow thing. It's all of this, right? If I didn't put the brackets there, right? If this would have just been like that, that would have looked like it was just this 4 times all of those, but it's not just the 4. It's going to be all of this that needs to be multiplied by the 2x plus 5. Okay, so we're going to go that one times that one, that one times that one, and so on, right? All right, so we'll go 4x times 2x is going to be 8x squared, and then 4x times 5 is plus 20x. And then negative 4 times 2 is going to be negative 8x. And then negative 4 times 5 is going to be negative 20. All right. And then I'll just simplify these again. So now we've got 8x squared and then 20 minus 8 is going to be 12x, and then minus 20. All right. So that's kind of it. We did the two of them, but then lastly, so just to keep track of this, it was all of this, right? That's kind of what we had left, and we were adding these. So it was a little off kilter there, but that's the idea. So now we just need to collect our like terms. So let's look at my x squareds. So my x squareds are those guys. And here I'll put boxes around the x's, and then just my numbers on the end too. I'll say something like that. Okay. All right, so 5x squared plus 8x squared is going to be 13x squared. And then 13 plus 12x is going to be 25, so plus 25x. And then negative 6 minus 20 is going to be negative 26. And there you go. It's that easy. Yes, so these ones get long, right? Like I get it that you guys are probably going, oh my god, yeah, but you'll get used to it. It's not like you've probably seen. It's not like a lot of hard math. It's just you got to be really careful. All right, so let's do this one because this is also another place with this minus sign where students will get confused. Okay, so again, I think the way that I would recommend doing this would be to just do the front part here first, and then this part second. Okay? All right, so let's do the first part first. Okay, so we'll go 2 times 3x and then 2 times negative 2, because this one's just a monomial times a binomial. Okay, so I'll multiply by both of those. So we got 2 times 3 is 6x, and then 2 times negative 2 is negative 4. Okay, so there, we did that one. Now, this minus sign is what's going to be a little tricky. And just before I get going, I just kind of want to remind you why this will be a little bit tricky. So in Math 9, let's say if we would have had the question like this, if it would have been like 3x plus 2 and then minus 4x minus 4. Do you remember how when we subtracted a different polynomial here, that all the signs switched in the other one? So this would all end up being 3x plus 2, and then this would be negative 4x, and then this would be plus 4. So the sign there was positive, and now it's negative. The sign there was negative, and now it's positive, right? So that's what happens when we subtract all of these, right? And another way of thinking about that is, okay, so if I had minus, let's say like whatever it was, 3x plus 2 or something, okay, is that this minus here is like having a negative 1 multiplying by these, right? It's like negative 1 times that, negative 1 times that, right? So we'll get to that in a second, but that's the idea here. So there's different ways that we could solve this. I could call this like negative 1 right off the bat, and then it would be kind of like a question like this one where it was positive 4 times all of those things. But instead, in my situation, it's going to be negative 1 times those things, right? So we could do it that way, or we could do this part all first and then change the sign in all of them after, right? So either one of those methods will work. I'll change the sign in all of them after. I'll do that one, I think, first here, but maybe I'll do the other one in a different example later on. But okay, so I just wanted to warn about that this minus sign would switch all of the signs all around funny, right? So just be careful about that one. Okay, so let's just do this part first, just ignoring the minus sign for a second. So we'll just keep in our mind that it's like 6x minus 4 minus all of this stuff, okay? So let's do this. We'll go 4x times 2x, and then make our rainbow like that. Okay, so we'll go 4x times 2x is going to be 8x squared. 8x squared. Okay, and then 4x times negative 5 is going to be negative 20x. And then 7 times 2 is positive 14x. And then negative 7 times negative 5 is going to be negative 35. All right, and then what we have to remember here, though, is that when we subtracted all of this, it's really like it's subtracting the whole thing. So all of this really should be in brackets still, the way I'm doing it right now. Okay, so let's just write it all again. So I'm going to write all of it. It'll be like this: 6x minus 4 minus 8x squared, and then I'm just going to collect these like terms. So negative 20 plus 14 is going to be negative 6x, and then minus 35. Okay, so now this is straight from like a Math 9 question, right? So we're minusing this other polynomial, the whole thing like in brackets like this. So again, you could just say, okay, well then I need to change all the signs in this one. Or you can think about it this way, where this is like negative 1 times all these things, right? It's the same thing. So either way, we're going to write this out now as 6x minus 4. And then this will become like negative 1 times 8 would be negative 8x squared. And then negative 1 times negative 6x would become positive 6x. And then this would become positive 35. Okay? Now let's just collect our like terms. And remember that typically we like to have our highest degree. So this one here would be out front. Okay, so we'd write that one out front, but I'll just kind of circle my like terms here first. Okay, so my x's are going to be here. And my just numbers or constants would be there. Okay. Okay, so now let's write it out. So I'm going to write this one out first. So this will be negative 8x squared. And then my x's would be 6x plus 6x, so 12x. And then negative 4 plus 35 is going to be positive 31. And there you go. All right, let's move on. Okay, I think that's the last one, right? Oh, no, another one. Okay, so when you have 3 factors, you can multiply in any order. So this, I was talking about this above. I just want you to see that we can do this 3 ways, where I'll just maybe do it 2 just for the sake of time here, where we could do this one times this one, and then this one times this one, and then multiply the other part out. So we'll do it that way first. So that would be 3 times here. So 3 times 2x is going to be 6x, and then 3 times 4 is 12, and then make my brackets again, and then write out 6x minus 2, and then do it again. So then we go that times that, that times that, that times that, and that times that. All right. So then 6x times 6x is 36x squared. 6x times negative 2 is negative 12x. 12 times 6x was 72x. And then 12 times negative 2 is going to be negative 24. Okay, and then I'll collect my like terms. We'll get 36x squared plus 60x, and then minus 24. Okay, and I'll just show you that we could do it one more way, right? Another way we could have done it was just ignore the 3 for a second. So here, I'll write it all out again, but we'll write it as, so 2x plus 4, and then 6x minus 2. Okay, so then I'm just going to ignore the 3 for a second here and just do this part. So that, like this one times that one, and then I'll put the 3 in after. Okay, so we can just kind of leave the 3 hanging out front, and then it'll be this one times this one, this one times this one, that, and that. Okay, so 2x times 6x is going to be, so this will all be in brackets too, right? Because it's going to be 3 times all of it in the end. So 2x times 6x would be 12x squared. 2x times negative 2 is going to be negative 4x. 4 times 6 is 24x. And then 4 times negative 2 is negative 8. Okay, so now that I have that all written out, well, you know what? Let's simplify that to make life a little easier. So we'll go 3 times 12x squared, and then this would become just plus 20x minus 8. Okay, and now multiplying this in, we end up with 3 times 12x squared is 36x squared. and then plus, so 3 times 20 is 60x, and then 3 times negative 8, negative 24. So same answer, right? It doesn't matter which way we multiply these, right? If we go this one times this one, and then the answer of that times this, or if we did it the other way where we went this one times this one, and then the answer of that times the 3. Doesn't matter how we do it, okay? All right, last question here, I think. Yep. Okay, so the painting shown is Deep Magenta Square by Richard. I don't know how to say that. The length of the red square in the painting is unknown. The width of the border around the square is 30 centimeters. Okay, so let's get our bearings here. So they're saying the border. So the border is this part, right, from like there to there. Ignore that little bit on the end. I think that was like where took like a snippet and like put this picture in, right? But yeah, the border is just from here to here. And that is 30 centimeters, right? So that's 30 centimeters, 30 centimeters. And it would also be true, let's do it up here too, 30 centimeters and 30 centimeters, right? So 30 and 30. Okay, so we can say that, right? So now it says, what's the polynomial expression representing the total area of the painting? So we don't know what the area, this is supposed to be red square, I think, right? Like all of this would be like our red square in the middle. We don't know what the side length of that is, but it is a square. So I know that they're both the same length there. And it wants an expression for the area of the whole thing. Okay, well, here, the area, remember area is just equal to length times width. Okay, well, we just need an expression for that now. So the area is equal to, okay, so now the length of this guy, so the length would be like, you know, this way, right? So if we look at this, this would be, okay, 30, and then an x, and then another 30. And that would be the total length, right? So I could just go like 30 plus x plus 30, right? That'd be the same thing. Or x plus 60, right? I could just add those 30s together. So it's just going to be, in brackets here, x plus 60, right? That is my length. That's you know, going that way. And that's going to be times, well, then the height. So the height would also, it's the exact same, right? It's going to be x and then 30 and 30, so x plus 60. There you go. So there is a polynomial expression for the area of our painting. So now it says, what is the total area of the painting if the red square has an area of 3,600 centimeters squared? So now we, well, you know what? Let's, I don't think I finished this last one either. We could leave it this way. It'd be fine to leave it this way, but typically polynomials are written expanded. So let's expand it too. So we'll do what we've learned already. We'll expand those guys. So this is going to be, the area would be x squared, right? X times x, and then plus 60x plus 60x, and then plus 3,600, right? 60 times 60. I'll combine these. So we'll say that the area is x squared plus 120x plus 3,600. Okay, so that's our, like, the same equation, right? The area and the area. We just wrote it out. We just expanded it. So now what this means is that we can put in any numbers, whatever this x turns out to be, right? We can throw that into here and here, into both of those. That'd be the same number, right? And then whatever that comes out to be, that would be the area, right? This is our function. Okay, so now it says, what's the total area of the painting if the red square has an area of 3,600? So they're saying the area of this is 3,600. Okay, so we've done this before. How can we figure out what the side length is here if the area is 3,600? So that's just going to be taking the square root of 3,600 is what we got to do here. That's going to give us our side length of a square. Okay, so if that's true, then the square root of 3,600 is equal to 60, right? So that's what x is. So x is 60. All right, so if x is 60, then that's all. We just need to throw in 60 into x an x here, right, to get out our area. So let's do that. So we'll say, so for b, the area is going to be equal to, so when I throw it in, I'm going to throw it in, I always throw it in brackets, so 60 squared plus 120 times 60 plus 3,600. So if you do that, I get 14,400, and then that should be in centimeters squared. Okay, so when you did this, just remember order of operations, right? Just do this part first, then this part, then this part, and then you add after. Unless you, the other thing you could do is if you're using your TI calculator, you could put this in, but just make sure you put this part in brackets so it knows to do that as one chunk, and then plus that. But yeah, either way.